Lesson 6.2, Substitution. I can solve a system of linear equations by the substitution method. So let's go ahead and look at the first practice problem. The problem asks us to use substitution to solve the system of equations. And so in previous chapter 6.1, we solved the system of equations by graphing, and the solution is where the two lines intersect. And so in this situation, or this method, we're going to use substitution in order to solve the system of equations. We're going to find where this line and this line intersect. How do we do that? Step 1. We solve one of the equations for one of its variables. So we'll take equation number 1 and we'll solve it for y. Right, y is a good candidate because it has a coefficient of 1. Saves us a step or two, and also we won't have any fractions in our solution. Right? So to do that, we need all the terms that don't include y on the other side of the equal sign. So we're going to add 3x to both sides, and we'll end up with y is equal to 3x. Great. We solved for y, and we don't have any fractions. Right? So we'll go ahead, and step 2 is substitute the expression from step 1 into the other equation. Then solve for the variable. So what does that mean? Well, since we have an expression for what y is equal to, we can go ahead and take our equation number 2, and we could substitute in what y is equal to, 3x, in place of y. So what we'll be left with is x plus 2 times 3x, not y, but times what y is equal to negative 21. Right? What did we do here? We substituted in 3x for y. And then we're going to go ahead and solve the equation by distributing out or doing the multiplication here. Right? So it'll be x plus 6x is equal to negative 21. We will combine like terms, and we will have 7x on the left side of the equal sign is equal to negative 21. Then we're going to divide by the coefficient in front of the x, divide by 7, and we'll be left with x is equal to negative 3. Great. So we're halfway there, right? What this tells us is that where these two lines intersect, x is equal to 3. So now we need to find what's the y where they intersect. And so we're on step 3. We're going to substitute in the value, the x that we found, from step 2 into any of the original equations. That means either here or here. Doesn't matter which one. Both will give you the same answer. And then we're going to find the value of y. So let's go ahead and try it by substituting in negative 3 into equation number 1. And we'll get negative 3 times negative 3. Right? And here we're substituting in negative 3 for x. Plus y is equal to 0. And negative 3 times negative 3 is positive 9. Plus y is equal to 0. We're solving for y, so we subtract y from both sides of the equal sign, and we get y is equal to negative 9. So what does this tell us? This tells us where these two lines meet, where they intersect, where they cross, is at x equals negative 3 and y equals negative 9. And so our last step is to write the solution as an ordered pair. Okay. And so we can also substitute in x in step 3 into equation number 2, and it will give us the same answer. All right, let's go ahead and try that. We have the original equation is x plus 2y is equal to negative 21. We're substituting in negative 3 for x, and we'll get negative 3 plus 2y is equal to negative 21. We're going to move the 3 to the other side by adding 3 to both sides of the equation, and we get 2y is equal to negative 18 divide by the coefficient, and we get y is equal to negative 9. Right? Same answer. So once you're at step 2, it doesn't matter which equation you substitute in x for. It'll get you the same answer. And then our final step is to write our solution as an ordered pair.